Greetings and welcome, friends. Mr. Waddy here. We were talking about properties of parallelograms the t'other day, and the definition of a parallelogram is it's a quadrilateral with two pairs of opposite sides being parallel. But then a whole bunch of other things were true as a result of that, and we proved some of those things. We'll even prove some in this here video now, assuming the end of the world doesn't happen. Find the value of each variable in the parallelogram. So one of the things we had was that opposite sides in a parallelogram are congruent. So z minus ocho is 20, something. Add 8 to both sides, 28, 28 is what z is. We also learned that the opposite angles of a parallelogram are congruent. So d minus 21 is equal to 105. Man, I'm getting lag. You guys spotting that lag? I'm spotting that lag. That's kind of not cool. That's kind of not cool. Can I close that? Does that help? All right. 105, add 21 to both sides. D is equal to 126. So yeah, so you can figure those things out. It's a wonderful thing. Here's question 7. It says, find the measure of angle B. What do we know? How can I do this? Yeah, there's consecutive angles in parallelograms were supplemental. So measure of angle B plus 51 is equal to 180. Subtract 51 from both sides. Measure of angle Bravo is equal to 129, I believe. Nice. What was your way? Opposite? Yeah. Yeah. Yeah, you're correct. That would also be a strategy to work. All right, here's another problem with just a whole bunch of information. I picked some portions of it. Find the indicated measure. LP. What's LP going to be? 7. Why is that? Because diagonals in a parallelogram bisect each other. They're not congruent to each other unless it's rectangular. Yeah, and then everyone's here. It's so wonderful. Measure of LMN. LMN. So that's this grande angle. What can I do here? Wait a minute. So here's 100. Okay, I think they're referring to this entire angle. Right, they're not just referring to that piece. So yeah, so this was equal to 7. This is equal to 80 degrees. I almost wrote 180, but that would make even less sense. All right, so this is 80 degrees. And then LMQ. Is it going to be half of 80? Oh! I almost thought that as well earlier this morning, so that's why I asked it. It is, however, I've got two parallel lines cut by a transversal. This isn't a property of parallelograms as much as it is a property of parallel lines cut by a transversal. It's going to be 29 degrees because alternate interior angles theorem. All right, so I did want to point that out, that the diagonals do not bisect necessarily the angles. All right, yeah, congruent. So k plus 4 equals 11. K equals, what's that, 7? And m equals 8. Bam. Done. Yeah, diagonals. What was the name of that theorem officially? Parallelogram diagonal theorem or something. One of those. I like this one. All right, so given that both of these are parallelograms, prove AB is congruent to FE. All right, so statement, reason, prove. So let's see, we've got some given information being that these are parallelograms. What's something I can say now? AB is congruent to CD by post-parallelogram opposite sides theorem. I like it. Bing, bong. What else can I say? Yep. Also by post. Bing. Right? For post applying to its own parallelogram. And then it looks like I can take this to the bank. Why is that true? Yeah, yes. Transitive property of congruence. Yeah. Cool. All right. Where's my slider? There we are. Last question. Let's prove the parallelogram consecutive angles theorem. All right. So let's see if we can prove that. Statement, reason, like so. What do I got to do here, you think? Let's start with our givens. This is a parallelogram, is the given. I'm going to say QR is parallel to PS. Why is that true? Yeah, def of para. How's that going to help me? I technically skipped a step, but yeah, consecutive interior angles theorem as well as def of sup. The actual consecutive interior angles theorem just says that these two angles are supplementary. And then, so I would have to have said that, and then by def of sup, those two add to 180. And then am I done? It looks like I think I donned it. All right, well, thanks for watching, internet friends. Have a good day. Bye-bye.